All right, so if you guys flip over to the back side of your notes, or the page 2, the top term gives us mutually exclusive or disjoint sets. So those are kind of going to be interchangeable words that we can use there to describe what I'm about to tell you guys. So mutually exclusive or disjoint sets. Those are going to be sets that have absolutely nothing in common, so no elements in common. So go ahead and get that definition down. So sets that have no elements in common. So for example, if I gave you guys a Venn diagram, like a universal set, what this would look like, okay? And let's say set A was odd numbers, and then set B was even numbers. Do odd and even numbers share any numbers in common? Well, no, right? Because even and odd numbers are totally different types of numbers, so they wouldn't have any elements in common. So let's say here was my set A, and again, set A was odd numbers. So if I had like 1, 3, 5, 7, and here's my set B, and that was even numbers. So 2, 4, 6, 8, so on and so forth. Okay, so that's just a quick idea of what mutually exclusive or disjoint sets would look like, just sets that have absolutely no elements in common. So the next section just quickly buzzes you guys through to determine if the following are mutually exclusive or not. So looking at set A and set B, 1, 5, 10, 15, set B is 2, 4, 6, 8, 10. They have the 10 in common, right? So therefore they are not going to be mutually exclusive because they share an element, right? Set A is factors of 10, so my factors of 10 are 1, 2, 5, and 10, so just numbers that multiply to 10, right? 1 and 10, 2 and 5. Multiples of 3 are 3, 6, 9, 12, so on and so forth. Do they have any elements in common? No. So therefore, yes, they would be considered mutually exclusive or a disjoint, okay? And last but not least, example C, set A is factors of 20. So factors of 20 would be 1, 2, 4, 5, 10, and 20. And then set B is factors of 13. And factors of 13 are just 1 and 13, okay? Technically, they share that number 1 as a factor, right? So they are going to be considered not mutually exclusive, okay, because they share that 1. They have that 1 in common, okay? The next piece of terminology you guys are going to be getting into is called the intersection or the AND case. So actually, you guys have seen a little bit of this when we did some Kahoot examples where we talked about the Titanic and we talked about like the and or the or. So your AND case or the intersection, that's going to be anytime you have elements in common. So elements in common. So if you were looking at a two-way frequency table, right, we looked at some of them where it was like, okay, you had to be a female and you had to like to play sports, right? We would look inside of our two-way frequency table to find those elements there. So you're thinking, okay, has to be elements that are in common for the intersection, okay? Now the symbol you guys are going to be seeing, it's like an upside down U, kind of like a horseshoe, okay? So I'm going to put that in quotations and say, this is our symbol for intersection. Okay, so an example of what this would look like, so let's say set A is elements of 1, 2, 3, and then set B is elements 2, 3, 4. And if they're saying, hey, figure out what set A and set B is equal to. So meaning, again, this symbol here, that just means your and your intersection saying, hey, between these two sets, what do they have in common? So if you look, you see between set A and set B, the only numbers they have in common are the 2 and the 3, right? So I say that's going to equal 2, 3 with my little notation brackets there, okay? If you guys look over to the intersection diagram they have here, so they're just referring to, okay, when two lines intersect, whatever point they have in common, right? That's what you're going to kind of be thinking for your intersection case here. And mutually exclusive sets obviously are not going to have any intersections, right? Because mutually exclusive, we just talked about, is when there's no elements in common, okay? So technically, mutually exclusive sets would never have an intersection because that would just kind of be the opposite of what the definition means, okay? So if we were to actually do a quick example, okay? So this is diagramming the intersection. So back to our bag of marbles, our red and white ones, okay? Set U, your universal set. This is all of the marbles inside your bag. So again, the numbers, and then the W represents white, and then the R represents red, okay? And now they're saying set R, right, are your 4 red marbles, and set E are 2 red marbles and 3 white marbles, okay? So if I go ahead and diagram set R right now, I'm gonna make like a kind of a circle. Set R, I'm gonna go ahead and just name off the ones that are in set R. So I have 3R, I got 4R, I got 5R, and I got 8R. So I'm gonna cross those off just so I know I've accounted for them. I'm gonna also cross them off in my set U just so I know I've also accounted for them there too. So I did 3R, 4R, 5R, and 8R, okay? And then if I do set E, well, notice how in set E, they actually have some elements in common here. They share the 4R and the 8R, right? The 4R and the 8R. So what I'm gonna do, here's my 4 and 8R. It's actually gonna overlap with my set E here because set E also includes those 2 elements, right? So I don't have to go rewriting these over here because the fact that I'm overlapping into set R means that, hey, set E also includes those 2 elements. So all I need to include off to the side are 2W, 4W, and 8W. Bum, bum, bum. And I'm gonna go ahead and cross these off also up here. So 2W, 4W, and 8W. Now the ones I have left over in set U that aren't in set R or set E, so 1W, 5W, and 9W, those can just get scattered outside. So I can put them outside of my diagram there. So 1W, 5W, and 9W, just to show they're not part of set R or set E, okay? All right, so now if I were to say, okay, well, what is set R and set E? So actually using my notation. Again, that and symbol is just saying, take these 2 sets and figure out what elements they have in common. Well, if you look over here at your Venn diagram, we already decided what those 2 are. It was just the 4R and 8R, right? So it's going to equal 4R, comma, 8R, okay? All right, and last but not least, guys, thank you for being patient with these notes after today. So you have your intersection, which is the AND case, and now you have the union, which is your OR case, okay? So now, when you have the OR case, that means you're going to actually combine all the elements in both sets, right? So I'm going to go ahead and write that under. So I'm going to write combine all elements in both sets. And our symbol for that, and now is actually going to be a U like this. So it's kind of like the AND symbol, but just flipped around. So the U is for union, or you guys can remember it that way. Okay, so I'm just going to write next to it symbol for union, okay? So again, all that means is, let's say, for example, I have set A, which is numbers 1, 2, and 3, and then I have set B, which is numbers 2, 3, and 4, and it's asking us, hey, what is set A unioned with set B, or set A or set B? So again, the or and the union, those are just kind of interchangeable words for that symbol there. And all I'm going to say is, okay, well, let me look at both my sets. I'm just going to combine them. So again, I'm not going to list out 2 and 3 twice, right? I'm just going to list out 1, 2, 3, 4. Those would be all the numbers between both my sets there, okay? All right, and finally, just to kind of wrap it up in the marble Venn diagram, to take that OR case and kind of apply it. So let's say my universal set are all these numbers in here, or all the marbles, right? And again, they're identified by W for white, R for red, and then just the corresponding number, okay? And then set R, it's actually the exact same example above, guys. So set R and set E are going to be the exact same numbers here. Now what we're going to look at is, okay, if I were to recopy my diagram, so the exact same one we have up top, so get that little overlap. So we have set R, set E. We know the 4R and 8R they have in common, they share. Set R just says 3R and 5R. Set E had the 8W, 2W, 4W. And then outside we had 5W, 9W, and 1W. So it's just me recopying my diagram. But now it's saying, okay, if I wanted to account for all the elements between both sets, right, that would literally be everything inside both of those overlapping diagrams. So how I would list that, if I were to say set R unionize or union with set E, I'm going to list out all of those elements between the 2 sets that I have shaded in my Venn diagram. So I'm going to have 3R, 4R, 5R, 8R, 2W, 4W, and 8W. I'm just not going to include the 1W, the 5W, or the 9W because that's not between both those sets there, okay? Just keep in mind that U, right, that just stands for your union, right, or what's going to be combined between all your sets.